Morning to all. The subject is electromagnetic electromagnetics field theory.
Sir, your voice is not audible.
Voice is not audible. It is audible now.
Yes, sir. It is audible, sir.
Okay. Okay. The subject name is electromagnetic field theory or electromagnetic waves. Basically, EMT, EMFT, or EMW. Mostly in your syllabus, EMW is integrated. Electromagnetic field waves. Electromagnetics waves. In this, we have today the first class. We have 5 units. Unit 1. Unit 1 is coordinate geometry. Coordinate geometry. Followed by vector calculus. Vector calculus. Vector calculus. Electrostatic. Magnetostatic. Electrostatic and magnetostatic. These are the content of the unit 1. And followed by we will go for today this class we will go for introduction to vector. Introduction to vector. Already you know this. Introduction to vector, coordinate geometry, or coordinate system you can write. This is not appropriate coordinate geometry. This is coordinate system, and followed by vector calculus and electrostatic. Followed by we'll go for magnetostatic. Unit 2. Unit 2 is Maxwell's equation. Maxwell's equation. And unit 3 is plane wave propagation. In different medium. Plane wave propagation in different medium. In various medium. Unit 4, transmission line. Unit 4 is a transmission line. And unit 5 is waveguides. Waveguide. This is a rectangular waveguide. So many type of guides are there, waveguides are there. Out of which we will discuss here a rectangular waveguide. Rectangular waveguide. These are the content in the syllabus. Unit 1, introduction to vector, followed by coordinate geometry or coordinate system, vector calculus, electrostatic, magnetostatic. Unit 2 is the Maxwell's equations. Unit 3 is plane wave propagation in various medium. Unit 4 is the transmission line. Unit 5 is waveguide, rectangular waveguide. This is unit 1 and unit 2. It will be in your unit basically midterm exam. midterm exam. And inter syllabus will be the end term exam. This unit 1 is bit lengthy unit. Okay. Okay. Now this point is for this I want to refer some book. I am writing that book name. You can write here book. Mostly I will follow one book. That is Principle of Electromagnetics. Principle of Electromagnetics. Principle of Electromagnetics, 6th edition. By Sadiku. So many books are there, but mostly we will follow this book. And for this entire syllabus, I will make problem solving sheets. Problem solving sheets, 2 sheets per unit. Problem solving sheets for problem solving sheet, 2 sheets per unit. In this problem solving sheet, you may get previous year GATE question, previous year IS question, and also some questions, some different book. Okay. And each unit you will have 2 sheets. Unit 1 2 sheet, unit 3 unit 2 2 sheet, and unit 3 2 sheet. Unit 4 is also a 2 sheet, but unit 5 I will make 1 sheet. Okay, total I mean 4 to the 8 plus 1 9 sheets. And meanwhile, to progress the syllabus, I will give you 2 assignments for evaluation point of view. 2 assignments. I will give 2 assignments. These problem solving sheets, you will solve these questions. Some question I will solve. Some question you will solve the questions. If you have doubt, you contact to me and ask the doubt. Okay, and assignment, these are evaluation point of view. You will solve this assignment and you have to submit this assignment. It may be on online mode, that means PDF format, or it may be in hard copy, right? Next assignment is over. Okay, and I will take 1 or 2 quiz. 1 or 2 quiz. 1 or 2 quizzes. These 2 are for evaluation point of view. These 2 are for internal evaluation point of view. Okay. Another very important point, please be interactive in the class. Please be interactive in the class. If you ask the doubt, then it will be better to me to explain all the concept in a good manner, so that it will be understandable to you. Okay, you should ask the doubts whenever you will not get this concept. Okay, another important point, some faculties, some teachers, and some students or senior students, the pass out students, those who are preparing for this competitive exams or for this basically university exams, they are saying this subject is a quite difficult subject. But from my perception, the subject is quite easy. From my perception, the subject is quite easy. It may be a bit difficult, but depends on you and your teacher. Who is teaching you? From my side, I will give 100% to convince you and to understand all the concept. For your perception, you should basically clarify your all the doubts. Okay, this is the bilateral deals. This is not unilateral deal. Basically, I will deliver the lecture and you will listen all this. No, this is the bilateral. Whenever I will ask some question, you have to reply that, and whenever you will ask some question to me, I will try to solve that. That's all. Okay. And now we'll start our syllabus, right? Now, first introduction to vector. This is a quite easy part. Already you know. Just briefly, I want to discuss, because everywhere you will get this vector, 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 vector. Till the end of the syllabus, everywhere you will get this vector. That's why I want to introduce this vector part, right? Fast. Okay. Of course, you know what is the basically definition of a vector. Anyone can say what is the definition of a vector? Anyone can say what is the definition of a vector? Okay.
Any quantity which has magnitude and direction is called vector.
Okay, but the definition is not sufficient. If you are saying any physical quantity that is having magnitude as well as the direction, if I will take current, suppose some electrical network is with you. This is the resistor and this is the resistor, and this is another one resistor here. If you take this type of a resistor, and let's say this is 5 volts, this is your 1 ohm, this is a this is 2 ohm, and this is 2 ohm. Now this current will start joining from here, and it will move, and it will move, and it will move, and here this I current, and here there will be I by 2, and here I by 2. This I current is having both direction as well as magnitude. If you see, this current is having direction. In this direction, current is moving, and it will have some magnitude. If you solve this, this is a 2 to 1, 1, 1, basically 2, and this will be 5 by 2 current, 5 by 2 current, 5 by 2 ampere current. This is having magnitude, as well as this is having direction, and the current will move in this direction. Current will not move in downward direction. Okay, this current is having both direction and magnitude. Can I say this current is a vector? Can I say current is a vector?
No, sir.
No. Then your definition is failed over here. Write the definition.
So the coordinates depends on the path.
Yes. Heading is introduction to vectors. Introduction to vector. Write the definition of a vector fast. Vector is a physical quantity. Vector is a physical quantity which is having both direction and magnitude, which is having the magnitude as well as direction. Vector is a physical quantity. What you told? Vector is a physical quantity which is having both magnitude and direction, and which satisfy the vector algebra. Which satisfy vector algebra. Vector algebra means, start the bracket, triangle law of vector addition. Triangle law of vector addition. Or parallelogram law of vector addition. Parallelogram law of vector addition. Close the bracket. This current is not satisfying the triangle law of vector addition, and this or parallelogram law of vector addition. That's why this is not vector. Right? The example of a vectors, we can say velocity, acceleration. You know all this: acceleration, force. You can write electric field, magnetic field, electric flux density, magnetic field intensity, magnetic flux density. These are various vectors. Next, write scalar. The physical quantity which is having only the magnitude. The physical quantity which is having only the magnitude, that is scalar. I want to take some example of a scalar. Speed, distance, volume. Anyone can say area is a vector or scalar? Area is a vector. ध्यान रखना, area is always vector. Area, a vector. If this area, basically, if you are saying area is a vector, what should be the direction of this area?
Perpendicular to the surface of.
Okay. That is one good terminology there. That is known as a normal to the surface. If you consider this is the surface, we can say this is the direction of the surface. 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 Or direction can be into the surface. Direction may be inward or direction may be outward. Okay, for this surface. Surface is always, or surface or area, that is always a vector. And but volume is a scalar. If you consider the length is a vector. Okay, length vector will be there, but distance is always a scalar. Okay, magnitude of that length, right? And the volume is a scalar here. And very important scalar I want to discuss, that is what we can say potential. Potential difference you can take. This is a V we can take. These are the various scalar quantity and these are the various vector quantity. Another very important point, basically whenever we are discussing this physics, basically electromagnetics, we are saying this is having electric field and as well as magnetic field. Why this term field is coming into picture? This is very important also. You see here, I am saying electric field. In details later we'll discuss this. If I will say electric field, why this term field is coming? What do you mean by this field? What do you mean by the field? Okay. Anyone? Similarly, also you can have this magnetic field. Why we're writing this field? Anyone can say, what is the definition of a field? Okay. If you want to write the definition of this field, please write the field definition first. Field is a mathematical structure. Field is a mathematical structure which is defined over a which is defined over a set. Set is F, which is defined over a set, that is F. I am saying this F is a set. Let's say F1, F2, F3, F4 are the elements of the set. If you can write, let F1, F2, F3, F4 belongs to set F. The set which satisfy, you can write the set which satisfy the following conditions. The set which satisfy the following conditions is called as a field. Is called as a field. Is called as a field. What are the conditions? First one, if F1 belongs to F, then there must exist, ये जो symbol है इसको बोलते हैं there must exist. If F1 belongs to F, then there must exist minus F1 belongs to F. Number one condition. Number two, B part, if F1 belongs to F, then there must exist 1 by F1 belongs to F, excluding F equal to 0, F1 equal to 0, excluding F1 equal to 0. Another one condition, C. If F1, F2 belongs to F, if F1, F2 belongs to F, then there must exist F1 plus or minus F2. यहां पे भी प्लस माइनस लिख सकते हो. Must in F. No, only plus minus you can write. F1, F2 belongs to F, then there must exist F1 plus minus F2 belongs to F. Multiply लिखा नहीं, D लिखो. If F1, F2 belongs to F, then there must exist F1 into F2 belongs to that set F. Then that set is called as a field. Then that set is called a field. Field is nothing but a mathematical structure, and which is defined over a field. That means, sorry, that is defined over a set. That means we can say the field is a set. The set which satisfies these conditions, that set is called as a field. Please tell me some example of this field. Field, finally we are saying field is nothing but set. The set which satisfies this criteria, that set is called as field. Now tell me some example of a field. Okay, if I will take, let's say field F is equal to, I am taking natural number set. Is it satisfy this or not? You see, if it is satisfy all the criteria, then we can say natural number set is a field. If you take 5 is the element, if you take 5 is the element of the same, there must exist minus 5. Minus 5 वहां पे है क्या natural number पे? नहीं है. Can I say natural number set is a field? No, natural number set is not satisfying this condition. That means natural number is not a field. Next, you go for this integer sets. Let's say I am taking this integer set I or Z. You can take. Now you see, take 5. Take 5 is the element of this I. Minus 5 should be there. Okay, minus 5 is there. But if 5 is there, 1 by 5 should be there. 1 by 5 is in the natural integer set. No, that means this is not also set. That is not also a field, right? अच्छा, आप लोग खुद बताओ अभी which set will satisfy all this criteria and that
Real
will be a
number.
field. Sorry,
Real number set.
very good. Real number. Okay, very good. Real number set is a finite set or infinite set? How many number of elements in your real number set? Infinite number of elements are there. That means this is an infinite set and we can say this is infinite field. Okay. Acha. Any other field do you know? Any other field?
Complex number field.
Very good. Complex number is also satisfying all these criteria. Complex number set. This is also a field. Any other of this complex number set is also infinite set, infinite field. But I need a finite field. You should give one example of a finite field. Please give that example. Please give that example. I need a finite field. You are saying real number set. Very good. Outstanding. This is basically a field. Complex number set. This is of course a field. But these two fields are infinite field, infinite sets. But I need a finite field. Tell me what is finite field? Anyone please? Think about this. This question is basically, I will discuss in the next class. You think about this. I need a finite field. If anyone want to answer this, please answer. Otherwise, in the next class, you can tell me. I need a finite field. Just think about this. The set which satisfies these conditions, that will say to be a finite field, or that should be that is called as a field. Okay. Basically, whenever I am writing, if I will write electric field or magnetic field, if I will write electric field or magnetic field, let's say, tell me any one example. Anyone can say what is the example of, anyone can say mathematical basically electric field example. Can I write this is a 2i cap plus 3j cap plus 5k cap. This I cap, j cap, k cap, the unit vector along x-axis, y-axis and z-axis respectively. Also, you can write this is a 2ax cap plus 3ay cap and 5az cap. These are the unit vector along x, y and z. These are the unit vector along x, y and z. Class कितना बजता होता? 45. Okay. You see, ये जो elements है, coefficient of x or coefficient of ay or coefficient of az, these are the elements from that set. What is that? Real number set. These are the field elements. These are the field elements. That's why we are saying this is the electric field. That's why we are saying this is electric field. Okay. It may be like this. Another one example I'm taking. I can take 2 plus 3i ax cap plus 5i ay cap. This I is iota, root of basically imaginary root over -1. This is 5az cap. This is also satisfying. This part is from complex number. This is from complex number, and this is from complex number. ऐसा टाइप वेक्टर कभी पढ़े हो? पढ़े थे कभी? Complex vector. This is called as a complex.
No, sir.
This type of vector also we can have. Okay, this type of vector we can have. But till this we discuss about this real vector always. But you can have this complex vector. Okay. Another one point, you see, another field I want to write, basically another electric field I want to write, you see now. E vector is equal to xi cap or ax cap plus 2xyz ay cap plus 5x square az cap. This is also electric field. But you see here, this electric field is varying with respect to the space variable. What are the space variable here? We can have the space variable like x, y, z, or we can time variable is a t, but we will not here use the time variable. The physical quantity which is varying with respect to space variable, those physical quantity are called as also field. Okay, here you see electric field is varying with respect to x, y, and z for different value of x, for different value of y, for different value of z, or different value of x, y, z. The field will be different. The field will be different, and that field at a different position. That means we can say, if you see this 3D for this position, you will have the electric field different. At this position, you will get the different electric field. At this position, you will get the different electric field. At this position, you will get the different field, electric field. Can I say this electric field changes with respect to space position? Of course. And these are the spatial variable. These are known as the space variable or spatial variable, which are x, y, z. These are called as the space variable or spatial variable. SPATIAL, spatial variable. Here this electric field varies with respect to x, y, z. That's why this is known as electric field. Similarly, also you can write this magnetic field. That magnetic field is varying with respect to also space variable. That is also term field is coming in that. Okay. I hope थोड़ा बहुत आइडिया लग गया क्यों फील्ड का बात कर रहे हैं. फील्ड बेसिकली ये फिजिकल क्वांटिटी जिसमें आपका क्या हो रहा है ना, स्पेस हिसाब से वेरी हो रहा है, स्पेस हिसाब से वेरी हो रहा है, राइट. इट मे बी ए स्केलर फील्ड, यू मे हैव ए वेक्टर फील्ड. वेक्टर फील्ड बेसिकली क्या होता है, जिसमें बेसिकली बोथ magnitude as well as the direction changes with respect to space variable, that is known as a vector field. Or scalar field, the field which varying the only magnitude with respect to space variable. Okay. Now I hope the field concept and magnetic field concept, magnetic field I am not discussing till this, I discuss only the field concept. I hope this field concept is clear to all. Next we will go for introduction to vector. Vector basically you see, this is a vector, A vector. I am writing this A vector as a A1 AX cap, A2 AY cap, plus A3 AZ cap. What is this AX, AY, AZ? Unit vector along X axis, Y axis and Z axis, right? अब कभी ऐसा टाइप वेक्टर देखे हो क्या, ए वेक्टर इज इक्वल टू ए रो एक्स सॉरी ए रो कैप प्लस ए फाई, otherwise you can write okay, no issue at all, a ro you can write a phi cap plus az cap. ऐसा टाइप वेक्टर देखे हो, नहीं देखे हो ना. अच्छा ऐसा टाइप वेक्टर AR cap, sorry, AR theta, A theta cap plus A phi cap. I hope you have gone through only this representation. You have not gone through these two. You have not gone through these two. देखो मैं जो बेसिकली यूनिट 1 में सेकेंड पार्ट बताया, सेकेंड पार्ट में क्या बताया, कोऑर्डिनेट सिस्टम. We can have three type of a coordinate system. One is a Cartesian coordinate system. Cartesian coordinate system में basically x, y, z का बात करते हैं, x, y and z का बात करते हैं. Another one coordinate system, I will discuss elaborate manner in that part. Another one coordinate system is known as the cylindrical coordinate. ये जो system बताया क्या, Cartesian coordinate. Cartesian coordinate system. Another one coordinate system is known as a cylindrical coordinate system. Cylindrical coordinate system. In this cylindrical coordinate system, But in Cartesian coordinate system, we can represent the any coordinate x, y, z, x, y, z. In cylindrical coordinate system, we can represent a rho phi z. This is known as a cylindrical coordinate system. Cylindrical coordinate system, you can write. Another one coordinate system is there, that is known as a, please all of you write. Spherical coordinate system. Another one is a spherical coordinate system. The spherical coordinate system. This is a thing about this cricket ball or football. The spherical coordinate system. It will have any point if you want to represent, that is r, theta, phi. यहाँ पे जैसे x एक्सिस, y एक्सिस, z एक्सिस होता है, यहाँ पे रो एक्सिस, फाई एक्सिस, z एक्सिस भी होता है, यहाँ पे r एक्सिस, थीटा एक्सिस, फाई एक्सिस भी होता है. एंड कॉरेस्पॉन्डिंग यूनिट वेक्टर यहाँ पे क्या लिखेंगे, यहाँ पे जैसे कॉरेस्पॉन्डिंग यूनिट वेक्टर ax, ay, az लिखे हैं क्या आप सब. These are the unit vector along x axis, y axis and z axis. Similarly, in this case of a cylindrical coordinate system, we can have the unit vectors. Those are a rho cap, a theta, a phi cap, a z cap. Similarly, also we can have in spherical coordinate system a r cap, a theta cap, a phi cap. What is this a1? A1 is nothing but the magnitude of a vector along x-axis. Magnitude of a vector along x-axis. Similarly, if you want to say what is a2, a2 is nothing but magnitude of this a vector along y-axis. Similarly, if I will say what is this a phi, you will say magnitude of a vector along phi axis. Similarly, if I will say what is AR, magnitude of a vector along r axis. Here you can say this is theta. A theta is magnitude of this a vector along theta axis. I hope थोड़ा बहुत आपको clear हो गया. Any vector can be represented in three coordinate system. One is a Cartesian coordinate system में हमें लिख सकते हैं. इसको हमें cylindrical coordinate system में लिख सकते हैं, and this can be represented in spherical coordinate system. Okay, any vector can be represented in this. Okay, all the details we will discuss whenever I will go for this Cartesian coordinate system, cylindrical coordinate system, as well as the spherical coordinate system. That is very, very important. Okay, to understand this coordinates, basically electromagnetic coordinate system should be very clear. Okay, and you know, basically any vector can be represented in this manner. Next, suppose you are having, this is a vector. This top one is a vector. What is the magnitude of this vector? Magnitude. What is the magnitude of this vector? What is this magnitude?
a1 square plus
Very good, very good, very good. A1 square plus A2 square plus A3 square root over. You know this, very good. And what is the unit vector?
divided by,
We can represent this unit vector as a hat or a cap. This is defined by
equal to a vector divided by magnitude.
Okay. Achha. Once you know this, basically this is a vector, this is the magnitude of this vector, this is the unit vector. ये जो वेक्टर है इसका डायरेक्शन जो निकालना है ए डायरेक्शन में होगा, लेकिन इसका बेसिकल मैग्नीट्यूड क्या होगा ना, दैट मैग्नीट्यूड विल बी 1. थिंक अबाउट दिस. बेसिकली इफ दिस इज योर, मैं कैसे बताऊं तुम लोग का, इतना थोड़ा सा जो यहाँ पे प्रेजेंट है आराम से समझ सकते हैं, राइट? ओके ओके, देन व्हाट कैन आई से. ओके, you see, all of you basically I hope you are visualizing this. Yes, no, yes. Okay. No. Yes. Please try to understand this. Basically, I am taking this is my x-axis. This is positive x-axis. This is a positive y-axis. This is positive y-axis. This is a positive z-axis. This is the point. This is a reference point. We can say this is the origin. This is my positive x-axis. This is positive y-axis. This is a negative y-axis. This is a negative x-axis. This is a positive z-axis. This is a negative z-axis. Okay. Okay. All of you see here, all the three axes. If you see this x-axis or y-axis or z-axis, these three axes are perpendicular to each other. Okay, or perpendicular to each other or orthogonal to each other. Basically, any vector, if you will go through any vector, this vector like this in Cartesian coordinate system, if you want to represent a vector, we should have the basis set, basis element. What is the basis set? The element in which, the set in which all the elements are orthogonal to each other. I am formulating one set here. I am formulating one set here. Ax cap, Ay cap, Az cap. Can I say this is a set? Of course, this is a set. And in this set, we are having, this is a one what code basically element. This is the another one element, and this is another one element. I can say this is the basis set. I can say this is the basis set. When I can say this is the basis set? Now, whenever the elements in the set are orthogonal to each other. If I have such elements in a set, that set is called as a basis set. क्या बोलते हैं इसको? Basis set. इसको क्या बोलते हैं? Basis set. If you want to write the definition, you can write here. The set is said to be basis set. The set is said to be basis set if the elements of the set, class कितना बजे तक? Oh, the set is said to be basis set if the elements of the set are orthogonal to each other or perpendicular to each other. And each element should have magnitude is equal to 1. And each element should have magnitude is equal to 1. Each element should have magnitude is equal to 1 or unity. That set is said to be basis set. Now, if you see, ये जो element है, ax cap is perpendicular to ay. Ax is perpendicular to Az, Ay is perpendicular to Az. Each elements are perpendicular to each other. Can I say this is the basis set? Of course, this is the basis set. Once we formulate the basis set, we can represent the vector now. Okay. In the next class, we will continue from here. Attendance तो direct हाँ Zoom से ले सकते. Thank you all. Next class we will continue from here. Thank you. Okay. I will take. Basically, दोनों लिख दो ना नाम. हाँ नाम लिख दो. Okay. Thank you all.